Hey, what's up, guys? Welcome to my first YouTube calculus video. Yeah. All right. You guys can read all that good stuff. Usually I would read it, but it would be very awkward if I did because, I typed it out. So, yeah. We're going to have fun. We're going to turn up with math. So pretty much where we left off on notes 20 is we started doing antiderivatives. Basic ones, nothing fancy. And here's what we did. And if you want to read what Dr. or Mr. Rogowski said from his second edition book, you can read all that good stuff. And if you get it, that's cool. You should be a math major. And if you don't get it, that's fine. Most high school kids, probably myself when I was in high school, I would read that and be like, I think I get it, but I'm not exactly sure. So in math symbols, all it means is this, guys. All it means is the integral of f prime of x dx, notice there's a prime on there right there, is equal to f of x plus c. That's all it means. And because I want a nice little deal like that, I'm going to put Chavez. For whatever reason, I don't see this in textbooks, and it might be because f prime is dy dx, and the dx's cancel, and, who knows. So there might be some issues going on with that. But that's all it means. Some rules, you already know this. So to take the derivative, you bring the n down and divide, and then subtract 1. And now to take the antiderivative, you do the opposite. So add 1 and then divide by whatever that number that is, and then we add c. Now because there's no limits on these integrals, we say these are indefinite integrals. And if you're reaching this YouTube channel by accident and you're not in my class and you're saying, dude, what the heck? This guy's not even doing sigma notation to find out what the antiderivative is of these functions. Well, relax. We haven't done area under curves, bro. Like, give me a break. We're just doing basic antiderivatives right now. So anyways, coming back at it. So this, obviously, this dx, that's written like 1 over x dx, and that it's ln of x plus c, but then there's an absolute value, and there's a reason for that, guys. The domain of 1 over x is all real numbers but 0, and the domain of ln of x is all positive numbers, but if you put an absolute value on it, now it has the same domain as this guy, see? So that's why they put the absolute value in there. And then these rules here are just the same ones, like your limits. So I don't think there's a big deal there. So let's jump right into the action and go to the second page and see what's up. Yeah, what's up? Okay, here we go. Example 1. Antiderivative of all this stuff. All right, before I do anything, that is for x to the half. And I would probably rewrite this as x to the negative 3. So antiderivative is, I put an equal sign here because I'm writing what the antiderivative of that is. Maybe I'll write it here on the right hand side. So 7x to the 5th, 7x to the 5th divided by 5, plus, I'm going to add 1 to that half there, 4x to the 3 halves divided by 3 halves, which is the same as multiplying by 2/3. It's the same, like if you're dividing by 3 halves, it's the same as multiplying by 2/3. That keep, change, flip deal. And then plus x to the negative 2 divided by negative 2. And then don't forget the plus c, plus c. Always, always, always insert that if it's an indefinite integral. Always. If you do not type that in, you will get points deducted. All right, so let's simplify it. 7 over 5 x to the 5th. You can write the x to the 5th on the top, no big deal. Plus 8 over 3 x to the 3 half. Let's see, minus 1 over 2x squared plus c. And there you go. That's it. Cool. Yay. Yay. Awesome. All right. I think we can go to the next one. Oh, okay. Sorry, guys. I heard some rowdy rumbling, so here you go. Guys, I'm kidding. I can't hear anything. It is a YouTube video. LOL. You guys are funny. Y'all are funny. All right, here we go. Evaluate 5 over x minus 2x to the negative 13. So this dude is obviously some type of ln. We put the 5 in the front. We write ln, and because the domain is all real numbers of 1 over x, so I write absolute value of x in there. I'm going to add 1 to that dude, so minus 2x to the negative 12 divided by negative 12. and then I put a plus c. So let's fix it up. Yes, you could leave it like that, but don't. So let's fix it up. 5 ln absolute value of x. Let's see, plus 1 6 x to the negative 12. I guess you don't need the 1 there, but I'm going to leave it. Plus c. And the reason why I didn't bring that x to the negative 12 down is because they gave it to me in the problem with it already, with a negative exponent. So I think it's okay. If you want to bring it down, that's fine. That's not a big deal. But there it is. That's it. I don't see any errors. If you find any errors, let me know. Well, okay. Again, I can't hear you, but if you find any errors, I guess just tell me tomorrow or something. Like, you know. All right, anyways. Example 3. Find f, given that f prime of x equals 10 cosine x and f of 0 equals 3. So, pretty basic, guys. So, let's find the original expression. So, here it is. F of x equals, the only way you're going to get 10 cosine x is if you had 10 sine x. The derivative of sine is cosine, so there it is. Put a plus c. And I'm going to tell you when x is 0, the y value is 3. So I'm going to put that in here. So I'm going to write 3 equals 10 sine of 0 plus c. So sine of 0 is 0, so that goes away. So 3 equals c. So that means my final statement, my final function, is f of x equals 10 sine x plus 3. And there it is. That's it, guys. That's your function. Easy, right? Pretty straightforward. All right, turn the page. We give you some basic trig integrals. Basic, lol. So yeah, so there they are. Nothing crazy. You know, you're just pretty much doing like the derivative of cosine of negative sine, but notice there's a negative there because you're going backwards. Oh, that almost looks like an equal sign. Let me erase it. So yeah, pretty basic, guys. And then I put a chain rule one here. While the antiderivative of basic trig integrals is straightforward, don't forget about chain rule deal, only going backwards to look at one in action. And notice, I can't give you anything extreme yet because we haven't done u substitution. When we get to those integrals, then we'll go ahead and do pretty heavy ones. But right now, we're just doing basic ones. So let's see. F of x equals, and I'm going to write, the antiderivative of sine is cosine. It tells me right here, negative cosine. So I'm going to write negative, and I'm going to put a little space in there. That's for a reason. Cosine of pi x plus c. But if I take the derivative of cosine pi x, negative cosine pi x, I do get sine pi x, but then times pi, and there's no pi in the front of this. So because there's no pi, I'm going to write no pi. Because there's no pi in front of it, to cancel it, you got to have a 1 over pi there. 1 over pi times pi is 1, so there it is. It cancels each other out. So there it is. And now I got to do this dude. You guys ready? I hope that made sense to you guys. Did it make sense? Guys, I can't hear again, so I don't even know why I'm asking. All right. LOL. I'm kidding. I got to ask. You know me. Let's continue. 2 equals negative 1 over pi cosine of 2 pi plus c. And I'm solving for c, guys. Cosine of 2 pi is 1. That's a 1. So because that's 1, so now I have 2 equals negative 1 over pi plus c. I'm going to move that to the left. And I'm going to write the c. Well, okay, fine. 2 plus 1 over pi equals c. And I'm going to substitute that dude right there. So my function is negative 1 over pi cosine pi x. Let's see, plus 2 plus 1 over pi. And that's it, guys. Pretty simple, right? Yeah, it was simple. All right, example 5. You just pretty much got to recognize it, guys. This one's straightforward. That one was one of your inverse trig functions. That's arc sine. So arc sine of x, and then you put plus c. If you take the derivative of that, you get this dude. So nothing crazy. I think I hope you get it. If you don't get it, it's not a big deal. This one doesn't come out too often on the AP exam. It does come out, just not extreme. Plus, the university would probably like it if you knew that. So yeah, know it. Okay, here we go. This one's coming right out of the UH exam or UH quiz that you're going to take in a little bit. If you look up on the board, on the right-hand side, I wrote the new UH quiz and it's due today. Is everyone looking? Haha, LOL. Okay, I'll stop because that's getting annoying. Yeah, so if you look up on the board, Antiderivative Quiz is due today, guys. And that's because it's really simple. It's only 10 questions. It's pretty straightforward. And this one right here that you're looking at is probably the hardest one in there. So let's go ahead and take care of this one. So let's see. Find f of x based on the following information. They give you the second derivative, and they give you these expressions. So let's go to the first derivative. So f prime, so all we're doing is taking antiderivative. So antiderivative of 2x squared is 2x cubed over 3. And then antiderivative of x is x squared over 2. And you got to write plus c. So now they tell you when x is 1, the y value is 7, 6. So I'm going to write that. 7, 6 equals 2/3. I plugged in a 1 in there. 1 cubed is 1. Minus 1/2 plus c. I'm going to move these to the other side. So I have 7, 6 minus 2/3 plus 1/2 equals c. And I'm going to get a common denominator. So I'm going to multiply this dude by 2 over 2. And I'm going to multiply this dude by 3 over 3. And you get, let's see, 7, 6 minus 4, 6 plus 3, 6. And if you can do this all in one sitting, that's cool. I do realize that some of you guys can probably do that in your head really fast. 7 minus 4 is 3, and 3 plus 3 is 6. And since the denominators are all the same, I got 6 over 6. So c is 1. So now I can rewrite what f prime is. F prime of x equals, let's see, 2/3 x cubed minus what? X squared over 2. X squared over 2. You can write that as half x squared. No big deal. Plus 1. Here we go. I'm going to find another antiderivative. So I'm going to write f of x equals, add 1 to the exponent, divide by that number. So 2/3 x to the 4th divided by 4. So I guess I can write it like this, and then put a little dot here too. I'm going to be multiplying those. Minus x squared over 2 times, oh, that's not x squared, guys. Come on. X to the third power over 2 times 3 plus x plus c. So here's what I have. F of x equals, let's see, 2 goes into 4 twice. 3 times 2 is 6. So I got 1/6 x to the 4th minus x third over 6. I can write that as 1/6 x to the 3rd as well. Plus x plus c. I'm going to plug in what I have here. Let's see, what do I got? F of 1 equals 2. So I plug that in. So 2 equals 1/6. 1 to anything is 1. Minus 1/6. Oh, look, they're being nice to me. Plus 1 plus c. These guys cancel out. Minus 1 minus 1. C is 1. So my function, f of x, is equal to, let's see, what am I? 1/6 x to the 4th minus 1/6 x cubed plus x plus 1. I look for that answer. And there it is. Yay. What do you guys think? Not that bad, right? Not that bad? Yeah, not that bad. You guys doing alright? Are you guys having fun? Okay, be nice to everyone, guys. Be nice to the sub. Okay, here we go. Sub, I hope you are liking this. This is really good stuff. You know, I mean, Math Life 24/7. I can do this all day. But you know, I mean, to each their own. You know, this is what I like. Alright, guys, here's that word problem I was talking to you guys about. So you see if you can apply it, do antiderivatives and all that good stuff. It's not that bad. You'll see. It's pretty straightforward. So let's just start. A car traveling with a velocity of 24 meters per second begins to slow down at t equals 0. So this is my initial velocity then. Velocity initial is 24. And everything's in meters per second, so we're good. With a constant deceleration of -6 meters per second, or -6 meters per second squared, whatever, you know, whatever. So there it is. And it says find the velocity v of t at time t. All right. So I know that the acceleration is -6 meters per second. And I know that the velocity is the antiderivative of acceleration. Because if you take the derivative of velocity, you get acceleration. So my velocity, v of t, is going to be equal to -6t plus c, some constant c. So all I did was do antiderivative, guys. So remember that my initial velocity is 24. So 0 equals -6 times 0 plus c. Oh, no, that's wrong. Initial velocity is 24, dummy. Not you guys, me. Negative 24 equals negative 6 times 0 plus c. And yes, I realize that you don't need this. I see some of you are saying, like, Chavez, I could have just inserted 24 into c. And that's fine if you see that right off the bat. Negative 6t plus 24. There's my initial equation for velocity in meters per second for time in seconds. And you're done. All right, let's continue. It says, letter B says, find the distance traveled at the moment the car comes to a halt. So to do that, I need to figure out what my position equation is. So I know that my velocity equation is negative 6t plus 24. So here we go. My position equation, S of t, is equal to the antiderivative of this guy. So negative 6t squared over 2 plus 24t plus c. Now the c, because I started at t equals 0, and at 0 you haven't traveled anything. You just start to slow down. So that means that my initial position is 0, or the distance traveled initially is 0. So my c is going to be 0, guys. So you can just drop it. So S of t is equal to negative 3t squared plus 24t. Now the next step, when do you come to a halt? You come to a halt when velocity is 0. Halt when v of t equals 0. So let's solve for when velocity is 0. So let's see, 0 equals negative 6t plus 24, move the 6t to the left, and I can see, I'm not insulting your intelligence, I know some of you can do this just by looking at it, and if that's the case, go for it, it's not a big deal. 6 goes into 24 4 times. So in 4 seconds, it comes to a halt. That's a S for second, not a 5. I don't see any mistakes. I plug in that 4 in here. So let's see, S of 4, oh, let me change the color. S of 4 equals negative 3 times 4 squared plus 24 times 4. I think we can do this by hand. I don't think we need a calculator. Let's see, negative 3 times 16 plus 24, 48, 96. I have to go in pieces, guys. All right, let's see, 16, 32, 32, 48. Oh, wow, they're being nice to me. So that is 48, and the distance, this is distance, so it travels 48 meters before it comes to a halt. So there it is, guys. I hope you guys liked it. I hope you guys enjoyed this first YouTube video. If you have any questions or comments, I guess you can either leave them down in the YouTube comment box, lol, or just see me tomorrow. Let's see, what should be my catchphrase? Thumbs up if you liked it. Subscribe if you loved it. I don't know. This is awkward. Okay, I'll see you guys later. Talk to you guys later, guys. Bye. Well, I got to figure out how to turn this off. There we go.